Hey everyone, that song reminds me of Tom Cruise in the movie Risky Business. So we're here at Big Ideas 4.4, Factoring Polynomials. And that song was really more specifically just looking at factoring a trinomial using really kind of a simple method of factoring. We'll look at that again, and we've reviewed that already, but we'll continue to see all the different ways of factoring again and review those, and then we have a few new ways that we'll be looking at factoring today as well. So that's the main thing we're doing, is the factoring of the polynomials, and we're going to look at something called the factor theorem at the very end. All right, before we do all that, let's go ahead and look at our cartoon of the day. So there's in the bleachers, a little boy flipping a coin. Heads, I listen to instructions my coach shouts, and tails, I listen to instructions my dad shouts. So that reminds me of my own son playing soccer. And yeah, the coach is shouting, and all the parents are shouting at the same time. All right, well, here we go on to factoring. So we're going to look at reviewing our factoring steps and methods. Okay, so on page 92 in your notes, there's a question there under Communicate Your Answer. It says, how can you factor a polynomial? And so you can write this right there at the bottom of that page, or somewhere on that page, on page 92, these different steps of factoring. So the first one that we're going to look at is always the first step in factoring, and that's just factor out the GCF, just the greatest common factor. So you got to look at the terms and see, is there a greatest common factor, either with the numbers or with the letters, variables that you have there, that you can factor out. So that's always the first thing to look for, and get that out first. And once that's out, then you have something that's left inside of the parenthesis. Once you've divided, basically simplified everything by the GCF, your GCF's in front of the parentheses. So it's kind of like, here's your GCF out here, here's the parenthesis and what's left inside here. So if you have three terms, like greatest, common, and factor, are three different words, then you're going to keep those. There's still going to be three terms inside your parenthesis. They're just going to be smaller terms. And so now at that point, you can then go ahead and factor some more. If it's a trinomial, there's a couple ways here. So if it's a trinomial with just has x squared, it starts off only with x squared or the variable squared, then it can just be the simple method, and you can just put down the two parentheses, start off with the x, and then the sign here, plus or minus. Now the sign might not always be plus and plus, it might be minus minus, or it could be a combination of a plus and a minus. That's going to be something you have to look at and remember. But then you have your numbers back here. That's what the song was actually just talking about, was this simple method. So the song was really kind of reviewing that method. Now, if there is an a in front of your x squared, if there's a number in front of the x squared, then you would probably want to do the star method. That's the best way, I think, to do this. So remember, it would look like this. So you can write this down over on the side here. You have an x and a line through it. This would be the star. The top of the star, remember, is the a times the c. So those two numbers times each other. So the a number times the c number gives you the top number on the top of the star. The bottom number is always your b number. So whatever number is in front of in this middle term, that's always going to be at the bottom. The top sides are always exactly the same thing. It's how this trinomial starts, with the number and the letter a, x on top of each side. So if it says 2x squared, you'll put 2x on top of each side. And then down below is going to be kind of the numbers, the question marks here I'm going to put down, as to you're asking yourself a question as to what two numbers multiply to give you this number, that would add or subtract to give you this number down here. That's going to be your numbers down here. It's the same question you would ask with the simple method. What two numbers multiply to give you c, that either adds or subtract based on that c sign here to give you this b number here. That's those numbers going inside there. So that's the simple method, or the star method, if you have a trinomial. If there's a binomial, then it could be a difference of two squares. So you got to look to see, is it a difference of two squares? Are the two terms perfect squares, and is there a difference between them, a minus sign in between them? If it is, then you can factor it to two binomials. This would be x minus 1, x plus 1. You'd break apart the x squared again. So you'd break this apart evenly. Going in here, so even if it was an x to the fourth, you could still do that, break that apart evenly to x squared and x squared. And so any even exponent is always a perfect square. And then this one would be the number times itself. Whatever number times itself gives you this number. Obviously 1 is 1 times 1, and 1's plus, 1's minus. There are always different signs inside here. If it's you might have a trinomial as well, and you could still, anytime you have a trinomial, you can do step 2 of simple method or star method, but you might have a special trinomial. That would be a trinomial square. And this one would be special here in the sense that you could break this apart with the x squared just like with the simple method. We could do that, but there's a special number here of 3, because 3 times 3 is 9 and 3 plus 3 is 6. So it's the same exact binomial. You're getting x plus 3 and another x plus 3. So you could simplify that to a binomial squared of just x plus 3 squared. Okay, so make sure you're writing all this down on page 92. If you didn't get all that yet, go ahead and pause and make sure you copy the rest of this down. But on this last one, you could, anytime you see a trinomial, factoring it with simple method or even star method. But if you can recognize that it's a trinomial square, and you can see, okay, well, there's a special number here. 3 times 3 is 9, 3 plus 3 is 6, so I can just quickly go ahead and do this without having to worry about those methods so much. You can get a binomial squared out of it. If you get 2 binomials that are exactly the same, you should make it into a binomial squared. All right, so I have a couple or 3 problems for you to try here, so let's go to those. Okay, so these 3 problems you can go ahead and just put down on the same page on page 92. See if you can find just any space there on page 92 would work. Just practice a little bit of this factoring, and I'm going to have you do this on your own. Let's just do one at a time. So try number 1, pause the video, do 1, and then play it to see if you got that right, and then we'll go on to 2 and 3. So you're factoring the polynomial completely. Make sure you're looking for GCF. There is a GCF in every single one of these. And then look, again, I put them down here so you can remind yourself just from looking at the screen what this is, or you can look at your notes. So go ahead and pause the video and try number 1. Okay, so hopefully you finished number 1 and now that's factored. Here's how we should factor this. First of all, factor out the GCF, which is x. So x would come out. We simplify each one of these by an x. So x squared minus 7x plus 10 is now in here. So you could use the simple method here to factor this to 2 more binomials. We don't want to forget about this x. We're going to keep the x in front and then 2 binomials. Now you could always use the star method, even with the simple method, you could still use the star method, even if it's a simple method kind of factoring. So if you did use the star method, you could do this. You could say, well, 1 times 10 is 10 on the top, and the middle term there is -7, -7 on the bottom. How does this start? Well, it's a 1x, so you just can put the 1x's on top there. And then the 2 numbers that multiply to give you 10, that add to give you 7, or 5 and 2. They're the same sign because it's a plus 10 here. They're both going to be negative because it's a -7. So -5 times -2 is positive 10. -5 and -2 combine to give you -7. So that tells you x minus 5 and x minus 2 are going to be your binomials here. So you could have done that with the simple method just by putting those binomials down, starting off with x's, and asking yourself what 2 numbers multiply to give you 10 that add to give you 7. That same question, 5 and 2. They're the same sign. They're both going to be this sign inside there. All right, go ahead and try number 2 now, and then play it after you finish number 2. All right, so you've done number 2 now. You got this one factored. We're going to first factor out a number 3 and some n's. We have 5 n's that we can factor out because there's 7 in this one, 5 in this one, so we can only factor out 5, the smaller amount. So 3n to the 5th power is going to be on the outside of the parenthesis. What's left from the first term is just an n squared, the minus sign. What's left from the 75n to the 5th is 25 because 75 divided by 3 is 25. All the n's are gone. And now what we have here is a binomial, but it is a difference of squares. N squared is a perfect square, 25 is, and it's a difference. So we're going to keep this 3n to the 5th still on the outside. We're going to put 2 more binomials down, and it's going to be n plus 5, n minus 5. We break the n squared apart to n and n. 5 is 5 times 5, and then just 1 plus 1 minus. All right, go ahead and try number 3 next, and then play it after you're finished. All right, so you finished number 3, and on this one we want to factor out a number and a letter as well. So 8, 16, and 8. 8 can come out. 8's the biggest number that can come out. You always want to take out the greatest common factor, the biggest number you can get out of there. And as far as the m's, the smallest amount of m's is m to the 3rd, so m to the 3rd can come out. 8m to the 3rd we will factor out, and then there's still 3 terms still in here. This now term simplifies to m squared, the middle one simplifies to negative 2m, and this one's just a 1 because we factored the whole thing out, so there's still a plus 1 there. So now we have a trinomial. We could factor this using simple method, or you might realize that this is one of those trinomial square ones because 1 times 1 is 1 and 1 plus 1 is 2, so it is one of those special ones. So either way, you're going to see, first of all, we're going to keep this 8m to the third still out there. You're going to get the same binomial. So if you did the simple method, you put the m's in front, the two numbers that multiply to give you 1 are 1 and 1, and they also add to give you 2. They're the same sign. They're both minus in here. So you noticing now they're both exactly the same. So the better way to write this then would just be with that GCF in front here, 8m to the third, with a binomial square next to it, m minus 1 squared, because there's 2 of these. So that is the best way to write that. So if you did anything wrong here on these, just fix it before you move on, and just try to do the better on the next ones. Okay, so now we go on to maybe a new type of factoring that you may not have seen before. You might have seen this before, but it's possible you may not have seen this. Everything so far we've done should have been something you've seen before in Algebra 1, or we may have even reviewed it already in Algebra 2. This next one you want to put at the top of page 93 where your vocabulary is. Right there, the second one down says factor by grouping. So you can just kind of put it right there. That's 4-term polynomials. So when you have a 4-term polynomial, you're going to use factoring by grouping. And I put a couple examples down here. You don't need to write these down just yet. I'll have you write some steps first, and then you can write these as we do the examples. But you can kind of at least get the idea of what they look like. There's 4 terms in these. So the very first thing to do with factoring by grouping is just to make sure that the polynomial is in descending order. So like these ones down here, you want to make sure it's in descending order. The highest exponent is first, and it descends from there. So 3, 2, this would be x to the first, constant number at the end. So that's the first thing you want to make sure of. After you made sure that it's in descending order, or maybe you might have even had to reorder it so it's in descending order, then you want to group the first 2 and the last 2 terms. So we're going to be grouping these first 2 and the last 2 terms there. After that, we're going to be factoring out the GCF from each group. So from this first 2 group, we're going to factor out a GCF from these 2. From the second group, we'll factor out a GCF from those 2 as well. Now, once we do that, we'll have GCFs out in front and a parenthesis with what's left in each one. And so at that point, there'll be a matching binomial, and that matching binomial is one of the binomial factors for your answer. Now, if you don't get a matching binomial, it means that either you did something wrong or factoring by grouping is just not going to work on this one. And it's possible that it might not be factorable at all, or it may take another way to factor it. There is another way to factor 4-term polynomials sometimes that where grouping doesn't work. But most of the time right now that you're going to, situations you're going to get into with 4-term polynomials, factoring by grouping is going to be okay to use. So once you've got that first binomial factor, your matching binomial is one of the binomial factors, then the second answer, the second binomial, the 2 GCF factors are going to create the other binomial factors. So the 2 GCF factors that you factored out from each group, they combine to create that second binomial factor. All right, so let's take a look at this example 1. You go ahead and write this down. You can just, somewhere up there again at the top of 893, it's just if you can find some space. We're actually going to do 4 of these, so I know you're going to have to put some, you might need to find some more space maybe on a previous page perhaps. So the first thing we're going to do is group. So we are descending order. This is in descending order. We already checked that. We want to group the first 2, group the last 2, so we can see these are our groups here. You can group them with parentheses. I usually just underline them. And now from the first group, we want to factor out the GCF. So out of these 2, we can see, well, 2 is the GCF number, and x squared needs to come out also. So a 2x squared is our GCF coming out, and what's left from the first one is an x, and what's left from the second one's 3. And then we're going to put, for the next one, our GCF of these 2. If there's nothing in common, if there is nothing in common, you could still factor out a 1. So that's what we're going to do on this one. We're going to factor out 1. So it's going to be a plus 1. It's got a positive sign here in the middle. So we're going to factor out positive 1. And then we still have the same exact thing because we really didn't factor out anything. we're just going to say x plus 3 still. So there's your matching binomial. So that's going to be one of your answers. The other answer is going to be coming from right there, those two that got factored out. So those two are going to be one of the binomials, and then your matching one is the other one. So we can say our matching binomial, x plus 3, is one of these binomial factors, and then the other one is what we factored out, the 2x squared plus the 1. There it is. Now at this point, if you see any more like difference of two squares, then you'd want to continue to factor, because you always want to factor completely. Alright, so I want you to take time here to try to number 2. So do number 2 on your own. Do it just the way I showed you here, and then go ahead and play the video and see if you did it correctly. Okay, hopefully you've paused the video and you've completed number 2. And if we want to first group the first two, group the second two. So out of the first two, we're going to factor out 2 as far as the number goes, 4 and 10. So they're both even. 2 can come out and an a squared. So 2a squared comes out. What's left is 2a plus 5. Out of the second two, the GCF here would just be the number 3. 3 can go into 6, 3 can go into 15. That's the greatest number that comes out. So plus 3, and then the parenthesis, and when we factor out 3 and divide each of these by 3, we get 2a plus 5 again. There's a matching binomial. So hopefully you saw that, you got that. That's going to be one of your answers. The other answer is going to be what you factored out there. So your answer for this should be 2a plus 5, the matching binomial, and those 2 that you factored out. Make your second one 2a squared plus the 3. That's it. All right, we have 2 more to do, and the other 2 now are going to have minus signs here between the 2 groups. So these 2 had plus signs, and that makes it pretty easy. These are the easier ones. We want to see what's going to happen when we have a minus sign here. That is going to make it a little more challenging. Okay, so for 3 and 4, again, we're just, if you still have space there at the top of 93, go ahead and put it up there. If you don't, you can drop down a little bit below, or go back to page 92 if you have more space over there. So for 3 and 4, now you're noticing that this one, there is a minus sign here between our 2 groups. So if we group our first 2, group our second 2, there's a minus sign in between the 2 groups. So that's going to cause a little bit of a difference. So the first thing, we want to factor out our GCF from the first group, just like we did before. So 5 obviously is the number coming out. There's going to be 3 x's, because this one has 3 x's here. So 5x to the third is going to come out. What's left from the first term is just an x, minus sign, and what's left here is just 1, because you factored the entire thing out here. So there's still got to be a 1 inside here, because this times 1 will go back to 5x to the third. Now on the next one, there's nothing in common like we had on a previous one. So we're just going to factor out 1, but because this is a minus 1 right here, we're going to say minus 1. We got to factor out a negative with that. So it's going to change the signs here a little bit. So when we factor out this negative 1 here, it's going to change this sign to a negative. So this one doesn't make a negative here, because when I distribute this back, okay, think about distributing this back into here. Negative 1 times x is negative x, like I have up there. Negative 1 times negative 1 is positive 1. So that's why I have to change this sign if I'm going to have a negative here, and I'm grouping it. If I factor out a GCF from this second one, and there's a minus sign here, our last number here, right here, is going to have to change signs for that to work out, because you want to always think about going backwards back to here. Negative times negative will make this positive again. Okay, so now we're just going to write our answer. Our answer here is going to be an x minus 1, because those are matching now. So x minus 1 is one binomial, and the other one's the 5x to the third minus 1, and you are done. On this last one, number 4, first thing you notice is they are all having an even number in front of all of them. So this is going to cause us to take out a GCF first. Even before we do the grouping part, we're going to have to do the GCF of all of the terms. And so that's always still going to be the first thing you look for. Is there a GCF in all the terms? In this one, there is 2. So we can factor out a 2, and we just simplify everything by 2 here. So now we just have an x to the third, x squared. This is now negative 4x, negative 4. Okay, so at this point, now we want to group these in here. So we're going to group these first 2, group these second 2. And I'm going to have you pause the video and now try to do that. Group these here and see if you can get your answer. Your answer is just going to have to make sure your answer has that GCF still in front. So at the very end, your answer is going to have a 2 still in front of parentheses. So make sure you do factor completely on this one. So go ahead and pause it and then play it once you're done. Okay, so hopefully you've got an answer for this, or at least tried this anyways. So we have to factor out a GCF of these two. It's just x squared is going to come out of this. So what's left there? I'm going to keep the 2 coming down here. Eventually, I'm just going to figure out what this first one's going to be. So x squared is going to come out. That leaves me with x and a positive 1 because I factored out the entire x squared. Here, negative 4 can be factored out. So negative 4 is out here. Now we have x, and this changes to a positive 1, right? Negative times positive will make this negative 4 here. So that's always going to change the sign. That's that special thing you have to do when this is a minus. And so now we see our matching binomial is x plus 1. So we're going to have a 2 in front of x plus 1. And then what we factored out, the x squared minus the 4 makes the other binomial. But here's where we got to make sure we factor completely, because that still can be factored because it's a difference of 2 squares. So we can factor this to 2 more binomials right here. So I'm going to keep my 2, my x plus 1 first, and this makes 2 more binomials after that, x plus 2, x minus 2. So you're breaking the x's apart, and basically break the 4 apart into even numbers here. Two numbers that are the same, 2 and 2 make the 4. One's plus, one's minus. And there's our final answer. Alright, so here we're going to now go on to another new factoring as well. Talking about cubes. Okay, so on your core concept, we're still on page 93. Here's some more special factoring patterns. So this is very new. You haven't seen this before. So sum of 2 cubes and difference of 2 cubes. We just talked about a difference of 2 squares. Now we're talking about cubes. And as far as cubes go, you can have a sum or a difference of the cubes. It doesn't matter. It doesn't have to be only difference. It can be a sum as well. You can have the plus in there, but they work exactly the same. So it doesn't matter whether it's a sum of cubes or a difference of cubes. They're going to factor the same way and using the same technique. So you don't have to worry about trying to figure out a different way for each one. So here's how we do this. We know that if we have a binomial and both terms are perfect cubes, doesn't matter the sign in between them. If they're just both perfect cubes, we're going to either have a sum or a difference of cubes. And that will always factor to a binomial times a trinomial. And so here's an example of one, a binomial here. 64 is a perfect cube number. It's 4 to the 3rd power. 4 cubed is 64. Obviously, you can see the variable is cubed. And then 1 is also a perfect cube because 1's a perfect everything. So numbers down here, 27, 8, those are also perfect cube numbers because 27 is 3 cubed, 3 times itself 3 times. 8 is 2 cubed. And so that's what they're showing you here. Those numbers are what's cubed. So you need to realize the numbers that are getting cubed. And here's how our pattern goes. We know it's a binomial times a trinomial. I usually put down the empty parentheses. I start with the binomial. And so you're just going to say whatever you're cubing is going to go here. So we're cubing A goes there. Whatever we're cubing for the second one goes next to it. So we're cubing B goes here. And then let's talk about the signs later. Then we can go into these 3 here. So for the first one in the trinomial, it's this first one that was here squared. So you're multiplying this times itself for this one, a squared. So this is a, so now this is a squared. For the last one in the trinomial, it's just this one times itself. So b times b is b squared. And for the middle one, it's these 2 times each other. A times b is the ab. And now as far as the signs go, the sign in the binomial, see, no matter whether it's a sum or a difference, the sign in the binomial is always going to match the same sign as the one in your problem. So that will always be the same right there. So you write that down. That sign there is always going to be the same that you have here. As you can see down here, this is minus because this is minus. They are the same. The first one in the trinomial is always going to be opposite of what that is. So if you have a plus here, you're going to have a minus here. It's always the opposite. So in this one, you can see on the one that's a subtraction, a difference, it's going to be the opposite, plus here in the first one in the trinomial. And then the last one is just always going to be positive. So your second one here, or last one in the trinomial, is just always positive. So you can see here's an example of this one. It's got a plus, so it's a plus here. It's going to have a minus then here, and always positive in the back. So same, opposite, and always positive. Here's same here as the one in the problem, opposite as the one in the problem, and then always positive in the back. All right, so you should be able to get the hang of this pretty quickly to be able to factor these sums and difference of cubes. Let's go ahead and practice a few of these. So right there at the bottom of 93, we're going to practice a few. Okay, so now at the bottom of page 93, we're going to do these 4 problems. You can just label them A, B, C, and D. We're going to be factoring these. These are going to be sums and difference of squares just to get some practice doing these kind of problems. Now, you may want to take a look at this in my classroom. At the front of my classroom, I always keep this poster here. And it's a poster I made with different powers on here, and I got the cubes up to 10 of them, the first 10 cubes, and that's kind of something you're going to need to know for this. So you may want to either take a screenshot or a picture of this. If you pause it, you can take a picture of that, maybe keep it on your phone or something, or take a picture of what's in my classroom, because these are always going to be helpful. I mean, I have more of them down here as well. You can see all the way to, these are just the most common ones that you see. So 5 of the 4th powers, there's 3 of the 5th powers, and just the 2 for the 6th powers. But the cubes we definitely obviously use usually up to the first 10. And so you need to know these numbers, that obviously 1's a perfect cube, 8 is 2 cubes, 27 is 3 cubes, 64 4 cubed, 125 5 cubed, 216 is 6 cubed, 343 is 7 cubed, 512 is 8 cubed, 729 is 9 cubed, and then 1000 is 10 cubed. So those are the numbers you need to know to help you kind of remember what numbers you're cubing to get these numbers. All right, so let's go back to our factoring here. So x to the 3rd minus 8, so we want to see, okay, 8, we just saw that was 2 cubed, and so we need to say it's going to use the 2 number. And we want to make this a binomial times a trinomial. That's always the pattern, so I'm always going to put my empty binomial down, then an empty trinomial down, a little bigger. And now we start with the first one in this binomial. It's what are we cubing to get this first term? So obviously we're cubing x, you can see that. So it's going to be x there. What are we cubing to get 8? That's the special number 2. That's why we needed to know that. So 2 is going to go there. I'm not going to put the sign there just yet. I'll do the signs at the very end. And now for your trinomial over here, there's 3 spots for the trinomial. The first spot here is going to be this first x times itself. X times x will be x squared. Then I usually do the last spot, which is the 2 times itself. 2 times 2 is going to give me the number there, which is 4. And then I do the middle spot, which is just these 2 times each other. So 2 times x is 2x. And now I can do the signs. So the sign in the binomial is always the same as we see here. So that's a minus on that one. This sign in the trinomial is always opposite of that, so it's a plus there. And the last sign in the trinomial is always positive, no matter what. All right, so go ahead and pause the video and try letter B. Letter B is very similar to letter A. You should be able to do that. Try letter B and then play it to see if you did this correct. Okay, so hopefully you've done that one now. On letter B, you got a binomial times a trinomial as an answer. For 64, we need to see that was 4 squared. We're going to use the number 4. We're going to put our binomial and trinomial parentheses down. Our first one here is going to be x again, because that's what we're cubing for the first term. For 64, we're cubing 4, so 4 is the number that goes here. For your first term over here is going to be x times itself, so that's another x squared there. And then the last one's going to be 4 times itself. 4 times 4, 16 at the very end. For the middle one, it's 4 times x, so it's a 4x in the middle. And then your signs, this one's going to be the same sign as we have in our problem. So this is a plus in the binomial. It's going to be opposite here for the first one in the trinomial, and then always positive for that last one. And that's what you should have as an answer. That is the answer there. Okay, so number C, let's do C together. For C, we have a number in front here, but notice it is a perfect cube number. It was one of those numbers we saw, so is 216. They are both perfect cubes. 27 would be 3 cubed, and 216 was 6 cubed. So you can use those numbers. But, however, since 3 can go into 6, that means 27 can probably go into 216. So if we tried that and said, okay, 216 divided by 27, what number is that? That's 8. So we can factor out this 27, and that would make it a whole lot easier for us. So if we factor out an 8 from a 27 from this, so 27 comes out, that leaves us just with the x to the 3rd. And then 216 divided by 27 was 8, which is also a perfect cube number. Okay, so that's important. If that wasn't a perfect cube number, then we couldn't do it. So it's also a perfect cube number. And now we can just go ahead and keep the 27 in front of this whole thing, and then put our binomial and trinomial parentheses down and just work with the x to the third plus 8, which is almost exactly the same thing as a here, except this was a minus and now this one's a plus. So we're still going to put in x in the first part of the parenthesis and 2 in the second part. This will still be x squared in the first part of the trinomial, and then the last one's going to be 4 again, just like we saw there. Still going to be 2x in the middle, and then our sign here will be the same sign as we have in our problem. So this time it's plus in the binomial, negative in the first one in the trinomial, and then always positive in that last one. And that's your answer. Just make sure you keep the 27 in front. So letter D, go ahead and try this one as well. There's also a similar thing happening here where you can factor out 4 from this and then get a smaller binomial that will still have perfect cubes. So you want to first factor out the GCF and then go ahead and do the sum of the difference of cubes after that. Okay, hopefully you did factor out 4, and now you have 8x to the third minus 1 left, which is a smaller, simpler one to factor. And so you would be putting that 4 in front of your binomial and then trinomial empty parentheses. And then you're working with what are you multiplying to get the 8 here? That was 2 again. Remember, we saw that before. So when there's an 8, that's a 2. But it's going to be 2x in front of this one this time. So 2x would go there. What are we multiplying to get 1? Well, that is just 1. And now for over here in the trinomial, the first one in the trinomial here is going to be 2x times itself, which is 4x squared. 2x times 2x. The last one is 1 times itself, which is still 1. And the middle one is 2x times 1, which is 2x in the middle. And then the sign here is going to be the same as we have in the problem. It's just minus. And the sign here is opposite what we have in our problem, which is plus. And our back sign here is always positive no matter what. So hopefully you got the habit and the pattern down on factoring these differences and sums of cubes. We're going to go on to our extra practice now, and you're going to pretty much do most of this on your own. I want you to do most of it on your own, and then just check your answers as we go through it. But first, let's pause and do a little quick joke of the day. What do you call a fake noodle? What do you call a fake noodle? An impasta. Impasta. Okay, so on page 94, you start your extra practice. I'm going to go ahead and have you just do these one. You can do them one at a time if you like to. That might be good. Let's just go one at a time, and then we'll go over each one. So go ahead and try it. Start with number 1. You're going to be factoring out a common factor on number 1, and then using a simple method factoring. All right, so hopefully you did this one, and we're going to factor out the GCF. So 20 can go into 220 and 600, so we're going to factor out that number, and we're also going to factor out an x because there's at least one x in each of these. So 20x is going to come out, and then we have our parenthesis. And from our first term, when we factor out 20x, we're going to be left with an x squared. From the middle term, it's going to be a negative 11x, and from our last term, it's positive 30. If you distribute that back into here, you'll get back to your problem. And now I just want to use a simple method factoring, keeping the 20x on the outside. We can break apart the x there, x times x, and then our parentheses. And the two numbers that multiply to give us 30, that add to give us an 11, will be 5 and 6. So 5 and 6 go inside there. They're both the same sign because it's a positive 30 here. They're both going to be negative. So they're both negative signs. There's our answer. That's our final factoring on that one. Okay, so go ahead and pause it again and try number 2. Here you're going to have a difference of, you're going to be first factor out a GCF, and then you'll be doing some difference of squares. All right, so our GCF on number 2 is m. You can see that's the only thing that's going to come out of this. So when you factor out an m, you're going to get m to the 4th minus an 81. But that is a difference of squares. Even though you have m to the 4th, you can break it apart evenly. So m stays in front of this one, and now 2 binomials, you're going to break apart m squared evenly here, and for 81, it's a perfect square. It's going to be 9 and 9. 9's that special number. 9 times 9 is 81. 1's plus, 1's minus. And we're not quite done yet, because since we still have an m squared, and we have a 9 as a perfect square number, we still have right there a difference of squares again, another difference of squares that we still need to factor this. So we're going to keep the m and this m squared plus 9. That will be a part of our answer, but now this will break to 2 more binomials. We're going to break apart the m to m times m and the 9 into 3 times 3. So it'll be m plus 3, m minus 3. Those are two more binomials that we have to see in our answer. So our final answer for this one are those 4 factors. There's actually 4 factors in that one. Number 3, go ahead and pause the video and do this one, which you can see is a sum of 2 cubes. So just like we were just practicing a minute ago, go ahead and try that with the binomial times the trinomial. Alright, so go ahead and you should have finished that one, got the binomial times the trinomial. I put the empty parentheses down first. What are we cubing to get this first one? Well, we said for 27, that was a 3, so it's 3a for the first one. And for 8, it's a 2, so it's 2b on the second one. And once you have those two down, it's pretty much easy after that, because now the first one in the trinomial is just 3a times itself, which is 9a squared. And the last one in this trinomial is the 2b times itself. So 2b times 2b is 4b squared. And the middle one is just these two times each other. 3a times 2b is a 6ab in the middle. And then the signs, this one here is always going to be the same as our problem, so it's a plus in the binomial. This first one here is always opposite of that, so it's a minus there. And the last one is always positive no matter what. And there is your answer. Number 4, here's a grouping one. So 4 terms, you're going to use the factoring by grouping. So go ahead and do the grouping on this one. And if this one does have a GCF, you want to factor the GCF out first and then do the grouping. Okay, so you should have factored out t to the third, because there's at least 3 t's in every single one of these. So t to the third is going to come out. You're going to simplify every one of these by 3 t's. So now 6 here is going to become t to the third. 5 will be t squared there. 4 is t. And this one's going to get factored all out, so there's no t's in that last one. And now you want to group the first 2, group the second 2 here. And so from the first group, now there's not a number that's in common. There's no GCF number, but there is 2 t's that can come out. So t squared is the GCF there. What's left now would be a 5t plus 2. And notice we do have a minus sign, so you can't forget about this. So in this one, there's, again, nothing in common. We're going to factor out 1. But as we factor out 1, we do need to make sure that we're going to change this second sign here to its opposite, so that when we think about multiplying 1 back into this, it goes back to -2. So, and it matches the 5t plus 2. It's also over there. So there's your matching binomial. So we can't forget about this one in black up here that we factored out originally. That's still going to be in front of our answer. So we're going to put that in front. And then we have the 5t plus 2. Our matching one is one of the binomials. And then t squared minus 1 is another binomial. But that one's special. It can still be factored some more, because that is a difference of squares again, with a t squared and a 1, which is a perfect square number, and the minus. Difference of squares. Now sums, if that was t squared plus 1, you can't factor those like you can with the cubes. Cubes, you can do the sum of cubes, but squares, it only can be difference. So we're going to still keep this part here, but then we're going to break this into 2 more binomials. So our final answer now will be the t to the third here in front, 5t plus 2, and then now this breaks apart into t plus 1, t minus 1. That's our final answer on that one. Alright, 5 through 8, just to keep doing one at a time here. Make sure you're doing these as well. Don't just wait for me and just copy what I'm doing. You really need to practice these. You really need to try to struggle through these yourself to see them. So start with number 5. This is got trinomial here. It is just a simple method factoring, so do it just like a simple method factoring here. Nothing to factor out. There's no GCF, but do a simple method factoring. Okay, so you should have done that one. So it's going to start with breaking apart the y to the 4th, and we're going to get a y squared and a y squared there. So there's a 2 parentheses. Then we ask ourselves the question, what two numbers multiply to give us 48 and subtract to give us 13? And that's going to be 3 times 16. So 3 times 16 is going to work there, because they're going to subtract to give us 13 as well. So a 3 and 16 will go in there. And then there are different signs. The bigger one, which is 16, is going to be negative, and then that means the 3 is positive. But now we need to notice that we have some y squareds. The one that's positive here, we don't worry about that one. That one's done. It can't be factored anymore. But the one that's negative is a difference of squares, so we need to recognize that can be factored to 2 more binomials. So we're going to keep that y squared plus 3, but now we're going to break this apart again with y being in each one. So y, and then 16 is 4 and 4. So it's going to be a y plus 4 and a y minus 4. So that's our final factoring. We need to make sure always factor completely. Okay, so number 6. Again, this one has a GCF. You're going to factor out a number here, and then it's got grouping to do. Factor by grouping after you factor out the GCF. Okay, hopefully you paused the video and you have done this one, number 6. So you should have factored out 5 and just reduced everything by 5. So now all these numbers 5s are 1s. So now you have p to the third minus p squared plus p minus 1. We're going to group the first two and group the second two. From the first group, we're just going to factor out p squared. So that's going to leave us with a p minus 1 still inside for this group. On this group, we're just going to factor out 1. And it is a plus, so we don't have to worry about changing any sign. It's just going to be plus 1 there, so p minus 1 still here. That's our matching binomial. We do not want to forget about the 5 originally that we factored out, so that's going to go first up front. And then matching binomial p minus 1, what we factored out creates that second binomial p squared plus 1. It doesn't matter the order you put the binomials in. I just usually put the matching one first, and then this one I created here second. And this p squared plus 1, they're both perfect squares, but it is a sum of squares. You cannot factor that. You can only factor it if it's a difference of squares. So we are done once we got that. Okay, so for number 7, here is one. It's just got 2 terms. So this one, you want to first factor out a number. There's definitely something that can come out of this with 810 and 160. Figure out the GCF to factor out, and then factor, I would say, probably a difference of squares at that point. Alright, so hopefully you did that. You factored out 10 on this one, because they both end in 0, so if you factor out 10, you end up with 81k to the 4th minus 16. And these are both perfect square numbers. 81 is 9 squared, 16 is 4 squared. So we can break this apart to 2 binomials there. So 10 still in front, and then we're going to see a 9k squared in front of each one there. And then 4 and 4. There, 4 times 4 is 16, and 1 plus 1 minus. So difference of squares always has a sum and a difference binomial. They're not the same exact binomial. There's always 1 plus 1 minus when we're dealing with a difference of squares. And so now at this point we want to look at the minus 1. Don't worry about the plus 1 because there's never going to be a factoring for the sum of any squares. But the minus 1, 9k squared, still a perfect square. So is 4. So we can factor that one again. And so we're going to keep our 10 and our first binomial intact. That's going to stay in our answer, but now this breaks apart. We're going to see a 3k in front of each one and a 2 in the back of each one. So 3k plus 2, 3k minus 2. That's our final factoring on that one. Number 8, here's another grouping one. Just go ahead and start grouping it right away. There's no GCF. Just go ahead and use the grouping method to factor this. Alright, hopefully you finished your grouping method, and we're going to group the first two, and that means we're going to factor out a to the third of that first group, leaving us with an a squared plus 1. And remember, we factor out the whole thing, we're still going to put a 1 there. This one does have a minus sign, and here we're going to factor out just a 1. There's nothing else in common, so minus 1 comes out, and we got to change the sign of the second one, so it's a squared plus 1, which those do again match. So your matching binomial, I usually put that first, a squared plus 1, and then what we've factored out creates the other one, a squared minus 1. But now look at this a squared minus 1. That's a cube right there, and 1 is a perfect cube as well because 1's a perfect everything. So we have a difference of cubes here that can be factored again to a binomial and a trinomial. So we're going to keep our original a squared plus 1. That will still be in our answer, but then I'm going to put a binomial and a trinomial parenthesis down to factor this sum of or difference of cubes. So starting off with the first part, what are we cubing to get the a cubed? Obviously the a, of course. What are we cubing to get 1? Well, that's always 1 as well. And so once we know those two, and the rest is easy. So the first one, the trinomial, again, is a times a squared, and this is going to be a 1 back here. 1 times 1 is 1. Multiply these two, you get just 1a. That's going to be in the middle. And as far as the sign goes here, it's the same here. So it's a minus in the binomial. This one's opposite of that, so it's plus. And then it's always positive in the back, the last one. And that there is our final factoring for that one. Okay, on page 95, we start with number 9 at the top there. So try number 9. This one you do have to factor out a GCF, and then there should be a simple method after that. Okay, so if we did this one, number 9, the GCF here is going to be 2x to the 4th. So the smallest number there is 2. That's the so it only can take a 2 out. That's the biggest number it's going to go into these other numbers. So 2 comes out, and there's 4 x's. That's at least all of them. So the smallest number of x's as well. comes out, and we just reduce each one of these. So now we have x squared minus 4x minus a 21 from each one. And now we use a simple method with just this right here. So keeping that 2x to the fourth on the outside of here are two binomials. You can just break apart the x squared to x and x. And what two numbers now will multiply to give us 21, that subtract to give us a 4. And the first thing you probably think of is 21 is 7 times 3, and that does subtract to give us 4. So the numbers are 7 and a 3. They are different signs because it's a negative 21. The bigger one's going to be negative, so 7's going to be negative, which means 3 is positive, and there we're done. All right, number 10 is another 4-term one, so factor this one by grouping. Okay, so now that you should have grouped the first two and grouped the second two, and notice there is a minus sign in this one, so don't forget about that. Out of the first group, we're going to factor out a 5 and 2z's, so 5z squared, there's still a z plus 1 left in that group. On this one, we're going to factor a minus 6 out, or a negative 6 comes out of that one, and there's going to be a z plus 1. Here's where we have changed that second sign there from a negative to a positive, because as we distribute this back, remember that's going to be negative 6. So now our matching binomial is z plus 1. That's we start with that one, and then what we factored out creates our other binomial, 5z squared minus 6. So those are the two binomials, and that was it. There, you're done. Number 11, go ahead and work this one out. There is a GCF to factor out here first, and then this one's probably going to require the star method, so I would use the star method on number 11. All right, so hopefully you did this one, and hopefully you did the star correctly. First thing just to factor out is just really 2 is the only number that's going to come out of this. So 12, 22, and 20. 2 comes out, so that simplifies the numbers a little bit. So 12 becomes 6, 22 is 11, 20 is 10 then. And now from here, we're going to need to use the star method. So I'm going to put the 2 on the outside and the front, and then my 2 empty binomials. I'm going to draw my star down, so the x with a line through it. The top of the star is going to be a times c, so 6 times negative 10 is negative 60. That's going to be on the top of the star. The bottom of the star is the negative 11. So that b number, whatever that is down below. The top of each side is just the 6x, it's the ax, it's however this starts, the number and the letter. So 6x on top of each side. I will eventually be crossing those out, but we're going to put 6x there. Below that now, we're going to ask ourselves the question, what two numbers multiply to give us 60? That subtract to give us an 11. That might take you a little bit of time because there's a lot of different ways you can multiply two numbers and get 60. So the way on this one that's going to work is 15 times 4. So hopefully you figured that out. That was 15 times 4 is 60, and 15 minus 4 is 11. So 15 and 4, it's going to be different signs. The bigger one's going to be negative, so negative 15, positive 4. And now we want to cross out our sides here. So as you can see, we want to simplify our sides if we can. It's kind of like a fraction situation. You have a 6 over 4, you can reduce that by 2. So 2 goes into 6x. We can make that into a 3x, and the 2 goes into 4 2 times. Over here we have a 6 and a 15. Well, 3 can go into both those numbers. So we reduce by 3, so that's 6x now becomes 2x. 15 becomes a negative 5 down there. So now each of these are the binomials. 3x plus 2 is one binomial. 2x minus 5 is our other binomial. And there we are done. All right, number 12. Here's another one we want to factor out a GCF. And then at that point, you will probably have some difference of squares to work on at factoring those. All right, so hopefully you did that one. You factored out 3 and an m squared because there's 6 m's here, there's 2 here. So 3m squared, this whole thing is going to come out. That's going to leave us with just a 1 here for our first term on the inside of the parenthesis. So 3m squared comes out, parenthesis 1 now is here minus 48 divided by 3 is 16, and we're taking 2 m's away, so m to the 4th is still there. And now 1's a perfect square, 16's a perfect square, you have an even exponent, which is always a perfect square, and you have a minus sign, which means it's a difference of 2 perfect squares. So this can be factored into 2 more binomials. So we'll keep our 3m squared still in front of this. We're going to break apart 1, just a 1 times 1, and then we're going to break this apart evenly as well. So 16 is 4, special number is 4 times 4, m squared, so 4m squared in each one of those. So we're going to see 1 plus 4m squared, 1 minus 4m squared. And now we don't worry about the one that's got the plus. That one is finished. the one that's got the minus is still another difference of squares. We can factor that again. So I'm going to keep my first two here, the GCF I factored out and the first binomial now. That's still going to be in our answer. But now this will now become two more binomials. We're going to still break apart 1 to 1 times 1, but now the 4m squared can become a 2m in each one. So 1 plus 2m, 1 minus 2m. And that's our final factoring on that one. Okay, so for 13 on this one, there's nothing to factor out other than just there is an x there, so we want to factor out the x. So it does have a GCF, it is x that you want to factor out, and then what's left you want to factor that. Now you may want to use star method, but it actually is a special one. It's going to be a trinomial square, so you might want to try to figure out how to factor it using the trinomial square method. Alright, so you factored the x out, so hopefully you've done this one now. You tried it. Remember, you want to try all of these. Factored the x out, and now this is what we left here, 4x squared minus 4x plus 1. And if you're having a hard time seeing this as a trinomial square, then you can still just use the star method. 4 times 1 will be at the top of the star, negative 4 at the bottom, and so on. You can keep doing that. But you might want to recognize that this is a perfect square trinomial, because if you do a times c, the 4 times the 1, that does give you 4. And the special number here, 4 times, or 2 times 2 is that 4, and then 2 plus 2 is this 4 here. So it is a trinomial square. So we can just do it this way with x here, binomials, break this apart evenly. 4x squared can be 2x and 2x. The 1 here, this last one, breaks apart to 1 and 1, and then we're going to get the exact same number sign in here, or exact same sign in here as the minus sign. They're both the same, they're both minus. So minus minus. And since these are going to be exactly the same binomial, the better way to write this would just be as a binomial squared. So x and then the 2x minus 1 squared. That's not a z out there, that's actually a 2. So that's the best way to write that. Okay, so for number 14, in this one, again, you want to factor out the GCF, and also you're going to end up with the same kind of situation as 13 with the trinomial square. So it'd be best if you could write it like this one was a binomial squared. So go ahead and try that one and then see if you got it right. Okay, so as far as the GCF, the number, it can't be any bigger than 5. 5 is the smallest number, so obviously nothing bigger than just 5 is going to go into 5. Then 5 can go into 70, 5 can go into 245. So we're going to factor out a 5, and the smallest number of m's is m squared, so 5m squared comes out, leaving us with our first term of m squared. Negative 70 is going to become negative 14m, because we're going to divide it by 5 and take 2 m's out. Divide 245 by 5, it's going to give you 49, and m squared comes out completely, so it's just the 49. And so here's where you can kind of see that you have obviously m squared, you can break it apart to m times m, so that's the first thing you kind of do as you're even thinking about doing the simple method. So you can do the simple method, but as you're doing that, you probably start to realize, okay, the two numbers that multiply to give me 49 that add to 14 are the same number. It's 7. That's your special number. 7 times 7, 7 plus 7. They're both 7s, and they're both, it's positive here, and so they're both going to be negative. So they're exactly the same here. So the best way to write it will be just with an m minus 7 squared. So your 5m squared outside here, m minus 7 squared here. And really, you could bypass this step if you recognize, oh, I can just go straight to a binomial squared. 7 times 7, 7 plus 7, and it's always going to be the minus sign here. All right, so we finished our factoring, and now we're going to look at just this last thing here. It's called the factor theorem. So it's very simple. Basically, all it's doing is it's going to ask us, is this binomial a factor of this trinomial? It's just going to ask that question. Really, the answer is just going to be yes or no. And so what you want to do is basically, is the remainder, if we were thinking about when we did last lesson on 4.3, the synthetic division, is the remainder of that division 0? So if we can do that, if we get a remainder of 0, then we can prove that it's a factor. And so let's try that on these next few. Okay, so on 15 to 17 here, it's just going to say show that the binomial is a factor of the polynomial. So we're going to show that in one of two ways, really. It says then factor the function completely. I'm not going to worry about factoring the function. We've done enough factoring at this point. I just want to do the first part really on these three problems. But there's two ways we could do that. One would be synthetic division, and the other one would just be evaluating, plugging the number in and seeing if you get 0 as an output. So you'd first need to figure out, again, like that multiplier number. And so this is, how do you know if this binomial is a factor of the polynomial? And the reason why would be because the remainder is 0. So if you get a 0 remainder, then you know it's a factor. That would prove that. And so we would want to say, okay, that this here is going to equal 0 right here to get a multiplier, right? We want to find out what's our multiplier number, or what's our input number going to be. So if we subtract 1, x is going to equal 1. So that's either our multiplier number or the input number. So for this first one, I'm going to just use it as an input number, and we're going to say f of -1. And this is going to start off by plugging in -1 here. So it's -1 to the third, -13 times -1, and then minus 12, and then just simplifying each one of these. So this will be -1 here at the beginning. This will be positive 13 next, and then minus the 12. And so now as we start to do this, take 1 away from 13, that will be 12 minus 12, which does equal 0. So if you have an input number from our multiplier, we input the multiplier in as our input. If the output is 0, that's always the remainder. That was the remainder theorem that we did on the last lesson to show us how to get the remainder. Remember, whatever we get as the output was the remainder, but if our remainder is 0, it shows us that this x plus 1 is a factor of that. So yes, x plus 1 is a factor. Number 16, on this one we'll do the same thing. We'll just make this equal to 0, so we can see we're going to add 2 to both sides to get our multiplier number, x is equal to 2. So we can either plug 2 in to x in each place here and then evaluate, or on this one I'm going to use synthetic division. So remember the synthetic division, we take our number here 2, we're going to kind of put that on the side over here, and then each coefficient, and everything has to be represented. So we start off with the x to the third term, that's going to be a 6. The x squared term should be next, which is included here, so that's going to be 8. The x term is next, which we have, -34. And then our final term is -12, the constant. So nothing was missing. If there was a missing term, we'd have to remember replace that or put a 0 in its place. We then leave a little space and draw our line. And then we bring that first number down to start the synthetic division. So now we're going to multiply 6 times the multiplier number. That's going to be 12. And then combine these two together to make 20. And now 20 times 2 is going to give you 40. That goes underneath the -34. Combine those together, that's going to give us 6 down below again. So when we multiply, we're going to get 12 again. And when we combine, here we get a 0 for this last one. I always separate that last one to show that last one is the remainder. We don't need to worry about these right now. I mean, this is how we could divide it and get a quotient. So our quotient is on this side, but the remainder is here, which is all we're concerned about on this one. The remainder is 0, so that tells us that x minus 2 is a factor of this polynomial. So yes, x minus 2 is a factor. So for this last one, number 17, go ahead and pause the video, and you can choose either one of these ways. Doesn't matter. See if this one, if x minus 5 is a factor of this. So either with the inputting method, kind of, with that multiplier, or using synthetic division. All right, for 17, hopefully you've finished that one. Now you're just going to check your answer. I'm going to use synthetic division on this one. So again, equals 0, our multiplier is 5. So I'm just going to use this synthetic division. You may have done it this way, and you can get the same answer that way as well. So I have x to the fourth, which is 2. X to the third is -12. X squared is a 6. The x term is 20. And there is no constant number. Now I don't need that constant number since it's the very last one. I really don't need it. So you don't have to put 0 on that last one. You could, and you'd find out that you wouldn't have needed it. So on this one, we're going to leave space, draw our line, bring down that first 2. 2 times 5 is 10. Combine those and get -2. -2 times 5 is -10, and combine those to get -4. -4 times 5 is -20. And we combine and we get 0. So that last number is the remainder number, so that would be 0. So since that is a 0 there, then we can say yes, this last one, x minus 5, is a factor. All right, so that concludes our lesson on 4.4. You want to go on to the assignment for this one, and I'll see you on the next one.